Inside your veins right now is a rushing, continuous river. It's a crowded environment, packed shoulder to shoulder with millions of red blood cells delivering oxygen to every corner of your body. But scattered among that massive red fleet are much rarer entities called leukocytes, also known as white blood cells. They make up just 1% of your total blood volume. While physical barriers like your skin and stomach acid act as a first line of defense, these cells are your critical internal security. They handle the microscopic threats that manage to slip past your outer borders. Usually, your skin keeps them out, but a simple breach, like a wooden splinter tearing through the epidermis, is all it takes to dump thousands of foreign pathogens directly into your tissue. Once inside, these invaders have access to a warm, nutrient-rich environment. If left alone, they will multiply exponentially, consume your resources, and eventually overwhelm your system, causing death. You survive this relentless, ever-multiplying threat entirely because of a highly coordinated counterattack mounted by a small army of short-lived, colorless cells. The moment the splinter breaches your skin, the damaged tissue sets off a chemical alarm. It releases signal proteins called cytokines into the surrounding area, drifting toward the nearest blood vessel. As the rare white blood cells patrol the bloodstream, they detect these chemical flares. The signals tell them exactly where the breach happened, prompting them to slow down and prepare to exit the blood vessel. They accomplish this through a process called diapedesis. The white blood cells stick to the vessel wall, violently flatten their bodies, and squeeze through microscopic gaps to enter the infected tissue. The first ones through the wall are usually neutrophils. These act as your primary rapid response unit, and they account for up to 70% of all the leukocytes in your circulation. Neutrophils engage the enemy through phagocytosis. They literally chase down bacteria, engulfs them whole, and then douse them in lethal chemicals stored in tiny internal compartments called granules. For threats too large or strange to swallow, like a multicellular parasite or a sudden allergen, the body calls in specialized backup, eosinophils and basophils. First, basophils dump histamine into the battlefield. This chemical causes local blood vessels to dilate and leak, forcing even more fluid and defensive cells into the combat zone. Together, these initial attackers operate as a blunt force trauma unit. They swarm the breach and sacrifice themselves to stall the bacteria, buying time for a more sophisticated weapon system to arrive. The next to arrive are the monocytes. Once these cells exit the bloodstream and enter the tissue, they balloon in size, transforming into massive structures called macrophages. Macrophages serve as the heavy cleanup crew. They consume dead neutrophils, tissue debris, and leftover bacteria. Crucially, they wear shredded pieces of the bacteria on their outer membrane, displaying them like a warning sign to the rest of the immune system. Those warning signs activate the lymphocytes, specifically T cells and B cells. This is the intelligence division of your immune network. Lymphocytes don't blindly swallow whatever is in front of them. Instead, they scan the shredded bacterial pieces displayed by the macrophages, analyze their exact chemical makeup, and begin designing a custom counterweapon. B cells synthesize this weapon by generating thousands of Y-shaped antibodies that flood the tissue. Because of their specific geometry, these antibodies lock perfectly onto the unique jagged antigens on the invading pathogen. Once coated, the bacteria are instantly neutralized and marked for disposal. This shift in tactics wins the battle. The initial chaotic wave of phagocytosis slows the infection down, but the deployment of intelligent, precision-targeted antibodies permanently breaks the pathogen's advance. The visible aftermath of this conflict is something you've likely seen. That pocket of yellowish pus forming around a healing wound is simply a graveyard of millions of white blood cells that died securing the area. But the victory lasts long after the wound heals. A few of those intelligent lymphocytes stay behind for years, maintaining a precise geometric blueprint of the defeated bacteria. This amazing phenomenon, called immune memory, guarantees that if the exact same pathogen ever breaches your skin again, your body will unleash an overwhelming antibody response before you ever feel sick. Modern medicine can track the scale of these microscopic wars by drawing your blood and running a complete blood count, or CBC test. This chart shows the baseline white blood cell count for a healthy adult, between 4 and 11,000 cells. A massive spike indicates leukocytosis, meaning an active fight against infection. Conversely, dropping into the danger zone means leukopenia, a dangerous shortage of defensive cells. Ultimately, the signs of being sick, like the fever, the sudden swelling, and the fatigue, are the macro-level evidence of a microscopic war. They are the physical proof that a billion-cell army is fighting and dying inside you to ensure your survival.